Welcome to the ArcGIS Rest JS session. I'm Dave Bowman, and today we're going to be talking about this library that we've built over the last 3 years called ArcGIS Rest JS, which is a JavaScript library for communicating with the various Esri backend APIs. So let's dive into it. Generally, this set of packages is going to handle authentication, including server federation. So it knows how to, once you have a token from a portal instance or ArcGIS Online, it can then handle federation with other ArcGIS servers. It handles the various date and object encoding requirements for sending and receiving items and various other requests with the platform. Additionally, it handles correct parameter encoding, making sure that the way you structure your search queries is going to be able to be interpreted correctly by the platform. And then if or when you actually experience an error, we wrap that into a very informative error object, which is much easier to handle inside of consuming applications. Let's talk a little bit about the goals when we set out on this project. What we really wanted to build was a consistent API so that we could build node applications, be they command line applications or express applications, as well as browser applications. So like IE11 and up, browsers are supported by this. We built a very lightweight library, allows you to include just the parts that you want. We'll talk about that in a little bit. It's written in TypeScript, but the actual outputs are vanilla JavaScript. You don't have to bring in any additional libraries in order to use this. We wanted to wrap up various API idiosyncrasies, right? You should be able to work with this set of packages without knowing all the idiosyncrasies of the underlying API. And kind of that lines us up with the broader JavaScript ecosystem, right? Today, if you're building JavaScript applications, for the most part, you just npm install a package and start working with it. And we want it to be completely aligned with that. And if you use TypeScript, we have typings for everything as well. Because again, it's written in TypeScript. As far as comparisons with other things that you might be familiar with from Esri, it's somewhat analogous to the ArcGIS API for Python. We don't have the same coverage of the entire Esri ecosystem that Python does, but we have a lot, and we'll go through the things that we have today. And then I know that it's going to be expanded. It's important to note that this is very different from the ArcGIS API for JavaScript. First and foremost, you will notice that there are no maps, right? This is a headless library for communicating with the platform. You can go and get features, you can push features into feature services or rows into tables, that sort of thing, but we don't have any ability to actually render that on a map. That's not the purpose of this API. The other thing that's different is this is an open source library. So it's on our Esri's public facing GitHub. So it's github.com/Esri/ArcGIS Rest JS. So far, over the 3 years or so that the project's been up there, we've had many different community people contribute pull requests to it. There's 50 different forks right now, a little bit more than that. So I'd put out there that, if you're using this library and there's some function that, some API capability that is not currently wrapped, by all means, go to the repo, submit an issue asking us to build it, or even better, submit a pull request. We've got a number of people that help curate this repository. And even if you can give us like just rough skeleton code, that helps things happen faster. And we can certainly help you bring your PR and your code along to hit the level of test coverage that we need. We'll talk a little bit more about that as we move forward. The actual repository is set up as what's called a monorepo. So there are multiple packages that are actually managed in a single repository, and the tooling for ensuring consistent releases and all that stuff is all automated and sits on top of that. So there are 7 packages that are really critical here. The request package is somewhat akin to Esri request. That's kind of the lowest level thing. It knows how to handle the lowest level communication with the platform. Then the thing that sits on top of that is our auth system, so that we have two classes for that, one for creating an application session and the one you'll use a lot more often, which is for creating a user session. And that's going to handle basically token exchanges, the federation aspects of stuff. There's a single package for dealing with the portal API, so this covers ArcGIS Online as well as ArcGIS Enterprise. We also have a routing package and a geocoder package, so they're very lightweight if you just want to deal with the hosted services for that stuff. We have a feature layer package, and so this is for consuming and working with feature layers and tables that are either hosted or on an ArcGIS server. And then we have the service admin package, which basically allows you to create, modify, and work with the services themselves, the layers in the services, if you want to create views, so on and so forth. Documentation, very important for any of these sort of libraries, right, is that people be able to find out how to work with them. So the doc is hosted on GH pages, right, so it's Esri GitHub.io/ArcGIS Rest JS. And this is what it looks like. If you just do a Google search for ArcGIS Rest JS, it will find this site and take you here. So it's a pretty standard sort of documentation layout. We have the packages listed on the left. Below the packages, we have the individual functions that are available in those packages. And we have the documentation about an individual function. There tends to be an example. And then we have all the different parameters that are required for that. At the bottom of the parameters list, there's a link that takes you into the source code. As I said, it's a little bit different than many other packages from Esri. Because it's open source, we can link directly to the source code. So if you're running into something with a particular function call and you're a little bit unclear about what exactly is going on, the documentation can deep link you right to the source code and you can go look at it. The other thing that's important here is to note that the documentation is automatically kept up to date every time we do a release because it is generated directly from the source code. So this is actually, that's the example that's in the documentation right there. This type of doc is called JS doc, and we use a compiler called TS doc or type doc, I think, and it generates that website for us. So it's kind of a virtuous cycle like that. Every time we make any change, you can see the automatically updated documentation. We also have a guides section. This is an area where we certainly solicit community feedback and additions. This documentation, these are stored as markdown files just within the repository. Relatively straightforward to write this stuff, and we would totally encourage anyone who'd, would like to just kind of help out with a project. If you use it and you enjoy it, it'd be fantastic if you could contribute a sample. That would be rad. Another thing about this project is it's got 100% code coverage. So this is what I was meaning earlier when I said if you submit a pull request, we have people that can help marshal that through the process of getting to this code coverage. The critical thing here, right, about 100% code coverage means that every statement, line, function, branch in the entire thing has some sort of, it's executed in the course of a test. Now, what that ensures, is that things are consistent release to release, because if you make a change in a function, you're going to have to make sure that that's covered by unit tests. The continuous integration system, the CI system that we have attached to this repo, basically won't let us merge pull requests that drop the code coverage numbers. So we're at 100%, we're going to stay at 100%. It's actually not that onerous a thing because it's a very low-level library. Writing the tests is not actually that much of a burden, and it certainly makes you feel better about it in terms of using this code. When you npm install it, you'll get 4 different things that you have access to. The TypeScript library is brought down, right? As well, there is straight vanilla JS ES6 modules, so you can just import those directly if you're not using TypeScript. UMD output, so if you are using a require-based system, you can pull that in. And then for Node, there are CommonJS modules, unless you're using, the right flags to pull in the ES6 modules. So if at all possible, use the TypeScript or the ES6 directly. If you are already have a system that's built around using AMD, UMD, or Require.js, then you can do that. And if you have to run on kind of older Node, or you're not running in with like ESM loading your Node project, then the CommonJS is there for you. So we've tried to make sure that under pretty much any circumstances, you can pull this in and easily use it in your application. Speaking of being used in applications, let's talk a little bit about where we use this at Esri. So I'm on the ArcGIS Hub and ArcGIS Enterprise Sites team. So we use it really heavily, and pretty much every single time we talk to either ArcGIS Online or the portal API, it's going to go through Rest JS. I mean, we're kind of the people who spearheaded this effort at the beginning, and we've done an awful lot of the coding. So we lean on it really heavily. The new Story Maps is leaning on this. Experience Builder uses the request and authentication layers of it. ArcGIS Urban is using parts of it. ArcGIS Solutions, which is something that's coming out. There was a talk slated for the Dev Summit, so there'll be a video about it, about how Solutions works, and that'll be released totally publicly kind of at the UC this year. But that is 100% based on top of Rest JS. Enterprise Sites, I mean, that's really kind of the same code base as ArcGIS Hub, so that all uses it. We've also got a lot of people in professional services using this because it's really easy to integrate into like virtually any type of an application, right? You just npm install and bada bing, you can start talking with the platform and handling auth, so on and so forth. Internationally, we've got Esri UK. They're big users of this so far in a lot of their applications. And then the startup groups that work with Esri, they also have adopted this, again, because it's very easy to add into existing applications. So I wanted to talk really about the philosophy about how we have designed and then implemented this library, because it matters, and you'll see kind of how this shakes out. So no surprise, right? The world is becoming much more oriented around mobile. More and more people are accessing the internet and digital resources via phones. And so if you want to have a good mobile experience, keeping the payload size down is really important, right? The smaller the payload, the faster it's going to transit the network, the faster it's going to be parsed and run on your device. So let's talk about small payloads. Each of these packages, right, this is kind of the worst case scenario. If you take the entire request package, it's 2.8K. Everything to do with talking to the portal is under 5. If you need to geocode, it's like a kilobyte of code that will be loaded in. Routing and service administration, this is on the order of bytes. We have a common library, which gives you a bunch of functional helpers. That's 217 kilobytes. So your very worst case, if you were to pull in everything, you're looking at under 15 kilobytes. And we'll get to the worst case part in a little bit, but we wanted to kind of say like, hey, this is pretty light, right? Like this is extremely light. That's less than jQuery. I think jQuery is like 23K, and that's included on 70 or 80% of the sites on the internet. So we're talking about, for 15K, you have a clean API to program against that allows you to communicate with almost everything that you can do online via Esri. So that's a pretty powerful thing. How does this work? Well, the philosophy behind this we took was to say, let's do this in a functional programming style. And in order to kind of understand how a functional style of development helps us get to these very small package sizes, as well as, that's the worst case scenario. We actually have means, if you have a build system involved, your build output will be much smaller than that. So to explain how we get to that, the easiest way is to talk about, what if we did this as objects, right? What if we said, okay, let's build a portal class, and how would it look like if we did that? And this is what the code would look like, something like this, right? Import portal from some package, create a new instance of the portal, and then execute a search or whatever. This is probably looks fairly akin to if you've worked with the ArcGIS API for Python. It kind of looks like this. And so this is nice, right? This is really nice. It's very friendly. It's very fluent. You can look at it and be like, yeah, hey, okay, I see what's going on. There is a little bit of a downside, though, to taking a class-oriented or object-oriented approach to this. And the main downside is that that portal object is going to have more than just a .search method on it, right? So if we did this as a class, we would have something like a constructor. That's probably an important thing. And then we'd have a whole bunch of methods on it. Now, this is just kind of structurally showing 3, but really in the portal thing, we've got about 95, maybe 100 plus different functions. And that includes things like creating items, deleting items, sharing items, changing the ownership of the item, so on and so forth. And of course, if you've got methods and you're doing stuff in a very object-oriented style, whatever you get back from those things is going to return instances of yet other objects, right? And so while the portal information model is not a super complicated model, we can see that it's also non-trivial, right? So if we take search, well, search is going to return items. And items, well, they're owned by a user and they're shared to groups. Users, well, they're members of groups. And all of this stuff is then connected to an organization. And so what you end up having here, right, is once you get one thing back, now you're getting like, well, I need an instance of the item class, and then I'm going to have probably instances of the user class and a group class, and then, well, at some point I'm going to drag in this organization class. And so this thing just starts kind of growing and growing. Now, this is not a problem if your application needs to use all or most of these methods that would be on the portal class, and you want to interact with all of the things that you get back from that. You want to interact with them as objects again. But your downside is that if you only need 1 or 2 methods, a class-based or object-oriented approach to this, you're kind of out of luck, right? Because the portal class has all of these methods attached, and it's going to return instances of other things. And it's very difficult for a build system to kind of detangle these things. This is classically called the banana and gorilla problem, right? This idea that, well, you want the banana, which is maybe just the search function, but you got the gorilla, which is the entire portal, and that was holding it, as well as the entire jungle, which would be all the other classes that are needed just as side effects of all of those functions that return other types of things. So this is a quote from Joe Armstrong, Coders at Work, a great book. So let's talk about how this changes if we simply just have a library of functions. Functions are fantastic, and particularly if you take kind of the approach of saying that it's a pure function, right? Your function itself, its return value depends only on the things that are passed into it. So that's the idea with these functions. There is no global state, and you're not going to do anything like that. So in your application, if what you need, you're just going to build maybe a simple application to allow people to clean up their account in ArcGIS Online. And so what you need is to import just the search items and then remove item from ArcGIS Rest portal. That's cool. Now, if you're using any sort of modern JavaScript environment, right, you probably have a build system involved, and your build system is going to be able to tree shake out all the other functions that are not actually used. So even though you just included those 2 functions, it will actually be able to very easily statically trace what's needed. So it'll go and get you the request functions that are kind of behind those things, but then you get a way smaller build output, because only the things that your code actually needs will be included. So this is the philosophy that we've taken, right? And this is really important. This is why when you go to this module, it's not like you just get a portal object and you call methods on it. You have to like import the functions that you want. It's a little bit more work, but the upside is everybody benefits from having a much more performant build process. So that's cool. But I know that there are some people out there who just don't want to work like that, right? So what's really cool, this is an open source project. And there's absolutely nothing that stops us from saying, okay, you know what, we could go ahead and compose some classes, right? We can have more packages inside of our mono repo. And if people are interested in doing this, we fully encourage pull requests around this so we could actually have ArcGIS REST portal classes or something like that. And so what you would be doing then is basically using these lower level functions and composing that up into a higher level construct, which is the classes, which would be fantastic. Now, if you were interested in doing this, I would strongly recommend picking up this book by Eric Elliott. It's also a series of blog posts that he's done at Medium, so you can read like 95% of the book on Medium for free, but it's kind of good to have in its kind of holistic format. Called Composing Software. And what he talks about is functional programming, and then the second half of the book is really about saying, okay, great, based on those functional primitives, how do you then compose an object layer on top of that in a meaningful way that can actually be managed very seamlessly? So that's really the kind of philosophy section of the talk. And at this point, we'll turn it over to Tom Leeson.
All right, thanks, Dave. So I'm going to try and bring some of those lofty functional concepts that Dave talked about back down to earth with some demos. But first, before I get into this demo that I'm going to talk about here first is I wanted to talk about the relationship between the ArcGIS API for JavaScript and Rest JS. So this is the Venn diagram of functionality, and there's a lot of functionality that they have in common. They both can query portal, they both have geocoding capabilities, they both can execute feature queries against feature servers. And of course, all of those things have the underlying needs of being able to authenticate and make requests. But there's a whole bunch of stuff that the ArcGIS API does that RestJS does not, and will never do. For example, interacting with maps and layers, showing those on scenes, and dealing with projections in the geometry engine, and data visualization and widgets. All that stuff is well beyond the scope of RestJS. Now, there are maybe a couple of things that RestJS does that may not be in the ArcGIS API for JavaScript. There's some service admin functionality, but for the most part, you can think of this as RestJS as having a subset of the functionality. And the reason that the demo that I want to show is actually a port of an ArcGIS API for JavaScript sample. And the reason I like this sample is because it uses all of the functionality inside the sample exists in that little area of overlap. It doesn't do any of the other stuff that you would use the ArcGIS API for JavaScript for. And the name of the sample is accessing ArcGIS Online items using authentication. And the idea with this sample, the best way to see what it does is just to take a look and run it live. The idea is that you sign in, and once you've entered the sign-in form, it's going to go into it's going to fetch your items that belong to your user account and show all the thumbnails for them on the screen. Okay, very simple, very rudimentary sample. Here, I've implemented this same thing, except I've taken the JS API out and I've put RestJS in instead. So what does this look like? Well, if I've done my job right, it's going to look exactly the same. And it does. So there's no visual difference here between here's the RestJS version and here is the ArcGIS API for JavaScript version. So what about the code? How's the code look? Well, here's the diff between the JS API version on the left and the REST version on the right. Now, it's, I'm not going to go through this line by line. It's the key idea here is that it's, there's more or less the same amount of code. Converting to REST.js didn't save you any keystrokes. Everything on the left-hand side has this more sort of object-oriented syntax where you're getting new instances of classes. Everything on the right-hand side in the REST.js realm, you're more just calling functions and passing around POJOs between function calls. So really, it's more than anything, it's just a syntactical difference for this sample, and that in and of itself wouldn't be enough reason to have rewritten this sample. So what is the reason? Well, let's go over here and go back and take a look. To understand, we really need to see the network tab. So when we reload this page and we see that the ArcGIS API for JavaScript, if we just look at all the JavaScript that was pulled in on this page, it's 275 kilobytes. And if we look at the REST.js version and look at the network tab for that and reload it, we'll see that we got just about 35 kilobytes here. And so it's an order of magnitude smaller. And so if you were going to be doing something like this, where you didn't have any mapping capabilities that you needed in your application, then if your application existed entirely in this area of overlap, then you really would benefit in terms of performance by using REST.js. Now, I didn't bring up the size difference to sort of bite shame the ArcGIS API. Obviously, it does a lot more, and probably in most cases, your application is going to need a lot more than what REST.js does. So if that's the case, if most applications do need all of this, then why does REST.js exist? Well, there's one powerful key pattern, and that pattern is the reason that all the other applications that that Dave talked about use REST.js. And this is the ideal scenario for using REST.js, and that is when you need to do something with the platform first, like maybe authenticate a user, sign them in. Maybe it's fetch an item, like an application item that has all the information like the title and other metadata about the application itself before a user ever sees a map. The ideal scenario for REST.js is when the map comes later. And the pattern that you use is you can do that and then lazy load the ArcGIS API for JavaScript only when you're ready to show a map. And when you do this, you get the best of both worlds. You get a fast initial load, but then you also get the full power of the ArcGIS API for JavaScript when you need it. Now, if you have questions about how you would lazy load the ArcGIS API for JavaScript, that's sort of a subject of a whole nother talk, but we have a few options. You can use a library like Esri Loader, will do it by default. You can also use the ArcGIS API's Webpack plugin if you're using Webpack and version 4 of the API. And it's very easy to load the ArcGIS API on demand only when you need it. So because this pattern is so powerful, I'm going to dive into it. We're going to take some time here to talk about how it works. So the first thing that, the main thing that people do with this pattern before they load the ArcGIS API is authentication. And you're probably familiar with, our platform has many ways to authenticate. And most of the applications that use Rest JS are going to use the OAuth. RestJS should work with all of these, but the common one that you'll see used is OAuth in browser applications. And there's some reasons for this. The first is that the OAuth is built into ArcGIS Online as well as Enterprise. It essentially comes with the platform. And much of the work that people do with RestJS is interfacing with, doing portal queries and that sort of thing. It also works with server via federation. So if you have a server that's federated with a portal, then we can use OAuth to get a token that will work with the server. But one thing you might not think about is how OAuth comes with its own UI. This little window here with this login form is actually a page that's rendered, in ArcGIS Online, and the form that we show there just shows in a little pop-up window. And ArcGIS Rest JS didn't have to render any of that. We, in fact, and if you're using token auth, you on the client have to have some way of gathering the username and password, and typically people do that by showing a form. Well, as Dave mentioned before, RestJS doesn't have any dependencies on anything like a UI library or anything like that, because we don't want to impose any opinions on consumers of this library. It's very low level. It's completely headless. So we're not going to build anything like this where we are generating a form for you, because we don't know what UI library you're using. But you can. So you just bring your own UI library, and you can write a simple form like this that takes in a username and password and calls the underlying token auth functions inside of RestJS. Now, we've got a folder in the repository called demos, and there's a lot of great examples in there of how you can use RestJS. And one of the first ones you probably want to look at if you're doing authentication is this browser OAuth 2 browser demo. And this code is actually so similar to what we showed before, or the functionality of this demo is so similar to what we showed before with the earlier demo, that I'm not going to take a look at it, but it's there for you to go ahead and look at, and you get a full sense. If you read that code, you'll understand everything you need to do to kick off browser OAuth. Now, so we always get this question, does RestJS work with fill in your acronym here, PKI or any of the other, IWA. And the answer is it should, in theory. A lot of the work that happens with those forms of authentication happens, at a level that is beneath the, say, JavaScript code like RestJS that's executing inside your browser. They happen lower in the stack. And so really there's not any work for RestJS to do there. The thing is that, in our production applications, we're using OAuth, so we don't have like what the ArcGIS API for JavaScript does, is a battery of users that can run tests manually with every release in different server environments and make sure that all those forms of authentication work. Because you may be doing authentication differently in your environment than other people are. And that's fine. We still want this to work for you, but the way that the model that we have is this is an open source project. So if we encourage you to try it out, and if it's not working, then you can open a new issue on the repository, and we'll try to jump in and help you understand what's going on. This has happened a few times already. We've had people open questions around authentication schemes that are ones that we don't use, and we've been able to make some small changes here or there that get things up and running. So let's look at what the code looks like when you are doing authentication. When you're doing authentication in the browser, first, all of our authentication code is in this package called ArcGIS Rest auth. It's one of the many packages that are part of the ArcGIS Rest constellation of libraries. And if you're doing auth in the browser, you're very likely going to be using our UserSession class. And yes, I said class. So we're not dogmatic about using, about functional programming. We're pragmatic, and in a sense like this, where you have some state that's going to live for the duration of the session, we use a class. And and a user session is, if you're familiar with the ArcGIS API for JavaScript's identity manager, the user sessions kind of works like that under the hood. It does the same kinds of things, but it's a little bit smaller, and it has a kind of a different API. So when you're working with a user session, we're only managing one user credential at a time, whereas Identity Manager typically manages many credentials. And there's a historic reason for this. Identity Manager was meant to manage, work with maps. And maps have many layers, and those layers could come from different servers and even different departments, right, within a organization, and even from different organizations, right? So you may be using a map that combines data from your own department, but may also be bringing in data from externally from, say, the county or state, something like that. Now, hopefully, nowadays, at least within your own organization, the servers are federated and you can kind of use a sort of a single sign-on paradigm, but there's still always this scenario where some layer in your map may require you to use an identity that is from an external identity store that's different from all the other layers in the map. And so this is why Identity Manager has to be able to juggle multiple identities. When you're working with REST.js, you probably don't need this. First of all, most of REST.js work is usually not done with servers, but is done against a portal. And even if you are working with a server, you're probably usually just working with one layer at a time. Now, if you have to work with more than one layer, in more than one server, more than one identity, instead of Identity Manager, you can just use multiple user sessions. This is something we do in the Hub application. And we have an area of our admin where we need to impersonate another user, and in that case, we just juggle two user sessions depending on the request that's being made. It's not that hard. But another option for this would be to extend the REST JS API. In fact, it was designed with this in mind. We thought that one day we might need to handle this situation. And so you can create something like a session manager that extends our base authentication manager class and handles this juggling of multiple user sessions internally. And there's an open issue that I've linked here from this slide that describes how to implement it. No one has done it yet, but it gives this sort of a blueprint, a roadmap of how to do that. So that's something that may come down the line. So another thing that you might want to do when you are working with a user session is handle just the way that Identity Manager does when there's an authentication error, to try again using a new session or using, so a very common scenario for this would be when a user has not signed in yet and you try to make the request but you get an authentication error and then you want to show the sign-in form for the user. And you can do this with Rest JS. In fact, we have a specific kind of error called an ArcGIS auth error. So when you get an error when you're making a request, if you inspect to see is it a type of ArcGIS auth error, it will expose a function called retry, and that retry function takes a callback in which you can do whatever you need to do to log the session in, log the user in. In this case, we're going to use this. We're going to do the OAuth sign in. We're going to kick that off by having the user session begin OAuth 2. And when that happens, now we're going to be able to continue on with our workflow. So there's an example that shows how to do this in the demos again. So it's just like the other example, the other demo, with the OAuth demo, except this will allow you to let the user try first to try and log in, and then when they're not authenticated, it will show the OAuth, rather than showing the OAuth up front. Now, there's some special considerations when you're working with the ArcGIS API for JavaScript, and as we said, we're going to be loading the ArcGIS API for JavaScript later, and what we want to do in this case is we're going to hand over anything that the ArcGIS API, that the Rest JS has already gotten from the platform. For example, the user's credentials, or perhaps it's gone and fetched some data. Now, it's a little easier to understand how to pass over data. If you've gone and fetched, say, an item for like a web map, and you have the JSON for that, you can, when you initialize the ArcGIS API for JavaScript after you've loaded it, you can just usually use the from JSON method that appears on almost all ArcGIS API classes to instantiate a new either portal item or a new web map, something like that, that you fetched with Rest JS. Panning over the session is a little bit more complicated, but it's not difficult at all, and it's a very similar idea. So the idea is that you're going to hand over credentials using session to credentials. So the user session method has this function called toCredential, and it will basically return the session in a format that the session information, like the username, the token, and the server, in a way that can be used with the identity manager's register token. So you just say, after you've logged in and after you've loaded the ArcGIS API for JavaScript, you just say Esri ID register token and pass it the output of session to credential. This goes both ways, so you can, in the less likely event that you've loaded the JS API first, but you need to then use Rest JS, you can you can take a credential from the authentication manager and you can instantiate a new session saying user session from credential. Again, we have an example in the repository there that shows how to do this JS API integration. It uses the retry and it uses the session to credential. And this is something that you'll be able to explore there. It's in the demos folder, and it shows you how to do all of that. I want to take a moment here to talk about JavaScript frameworks, and the reason is if you're using, if you're not using the ArcGIS API up front in your application, you're probably using a framework to do things like manage the layout or maybe routing or something like that, or to render, using it for its component model, that sort of thing. And Rest JS, this is going to be kind of a boring bit of the talk because there's not much of a story in terms of integrating. It's really no different than any other library, which if you're used to the integration story with the ArcGIS API for JavaScript, this should be a refreshing change, the fact that you don't have to do much work. Basically, you install the packages that you need, and don't install the packages you don't need. For example, if you don't need geocoding, you don't install those. And then you import the functions that you need from those packages. And these, RestJS will work. Is distributed as ES modules, so it will work with any bundler like Webpack, TypeScript, Rollup, and in fact, the bundlers will, if they support tree shaking, they will tree shake out just the functions that you need from those packages. And the final step is, when you're ready to use one of those functions, you're going to call it from within whatever area of your framework, the appropriate area of your framework. Now, that appropriate area of your framework is kind of the tricky bit. It's basically anywhere your framework is, recommends using a data fetching library. Oftentimes, if you're doing this from within a component, components in any framework will have a lifecycle method that is something you can do as a place where you can fetch data. In this case, for React, it would be component did mount. There's a little bit of an extra step in dealing with Ember. Ember CLI has this notion of an add-on, which is kind of a plugin for their CLI, and they typically just wrap packages. So in this case, you wouldn't install the REST packages themselves. You would just use the appropriate Ember CLI plugin. Because we use Ember in the hub, we've open sourced a couple of these. So if you need the portal type functionality, you would use ArcGIS Portal Services. If you need server functionality, you would use Ember ArcGIS Server Services, and it's going to pull in the appropriate layers. And both of those use a plugin for Ember's Tori authentication system that will wrap up the auth. So we've got some examples that use different frameworks. Some of them are inside the demos folder, like this Vue demo. And then we've got a couple of more full-featured applications that go kind of beyond a demo, and we'll take a look at those. So first, the Vue demo is it's that same OAuth demo that we looked at earlier. It's just implemented in Vue, and this is a really great way, if you go look at this, to understand how you can tap into Vue's lifecycle methods to use REST.js. If for an Ember example, every year at Dev Summit we have a workshop where we build an application that is built with Ember, and it uses REST.js to fetch items and log people in, and then fetch items, show them in a list, and then it hands over those items to a ArcGIS API map, and they get displayed on the screen as graphics. And so this is it shows the full life cycle of this pattern we've talked about, where you use REST.js first and then lazy load the ArcGIS API, and we hand over the data to the ArcGIS API. Now, this year we've built that same application as a React application, and so I'm going to do a little demo here with that to give you an idea of what it's like to use this. So here's the application itself. It's called Create ArcGIS App, and like I said, you would just search for some term, and then what that did was it executed a search against the ArcGIS Online API here for trails, and you can page through the results, and each time you're making new requests, and REST.js is making those requests for you and returning the items and then handing them over to the map, which is just displaying them. The map is not doing any work in terms of fetching the items or anything like that. So to understand how this works, we could also search for, we could sign in, and now we see that that I've been logged in as myself, and we could search for, And now we see a couple items here where I'm the owner, and if I sign out, those will go away. So what we're doing is we're not only authenticating the user, but we're also passing the user's identity along in the form of a token with the search requests. So this really gives you how, the building blocks, the tools you'd need to build a production application with RestJS. So let's take a look at how it works. First, the application itself is here in my repo. It's called Create ArcGIS App under my GitHub username, Tom Wason. And the first thing we're going to look at is that sign-in code. So that sign-in button there ends up executing this simple sign-in function. And that function is going to call UserSession begin OAuth2. And it takes in a client ID, the portal, which is typically just www.arcgis.com, and the fact that we want to use pop-up and the location of a redirect window. So if you've used OAuth before, all of that would look familiar. And what's great about this is that this is all we need to do in terms of RestJS. This begins the OAuth process, and if it's successful, then we will end up down here where we can just save the session. In this case, I think we stored in a cookie so that we can read it for later. Speaking of which, when we go down here and look at that save session code, we can set a cookie that will expire the same time as the session does, and the user session has this serialized class, which just takes the session state and serializes it to a string. And so it also has a corresponding deserialized class we can use whenever we load the application to read in this previously session. So those are some handy little functions there. Now let's take a look at the other thing that this application uses RestJS for, and that's the search. So here we're going to search for items, and there's a lot of React code going on up here in this previous part, but the key is this. Search items is the function that we pull in from RestJS, right? We pull it in from portal right here. And then down here in search items, we are going to take in the parameters we've read in from the query string of the page, and the parameters are the search term, Q, the number of results, and where we start, so that's the pagination stuff. And then critically, we also pass in the session. Now, if a user's not logged in, that session will just be null or empty, and so it will just execute a query, an unauthenticated query. And then once we get the results back, then we update the page's state with the results, and that's what renders the table and the and the grid. So that's how you can use that. Now I want to talk about a little bit about Node. I'm going to hand it over to Dave in a second here to talk more about sort of Node command line tools, but there's one specific thing in Node that has to do with web development and with web applications, and that is, you probably know this, but the ArcGIS API for JavaScript cannot be run in Node, and of course there's not much need to, right? The ArcGIS for JavaScript is really focused on rendering interactive maps, and there's no need to do that in Node. However, there is that little area of overlap of things between ArcGIS for JavaScript API and RestJS, and that area has some things that we might want to do in Node, and that's fetch items and authenticate and all sorts of things like that. And so conveniently, RestJS works in Node. Now, the one area that I want to talk about is isomorphic or server-side rendered applications. And these are applications that have JavaScript code that can be executed both on the client as well as the server. And the reason for doing this is that you can output the page. You can render the page on the server, the initial page request, and it will come back in a form. The HTML will be returned, and this is useful for SEO. So if you ever, like on a social media site, if you ever shared a web page and you get this sort of rich, not just a link to the page, but you get this sort of rich information like the title and some description information. All of that stuff comes from server-side rendered meta tags. So this is good for both performance and SEO. In reality, what we have found and what I've seen others have found is it's really hard to do this right. The frameworks have created some turnkey solutions to help you do this, but even then, it can be hard to do right. But if you are trying to do this, the important thing to take away from this is you can use RestJS to do this for you. So I've got an example using one of those turnkey solutions from the frameworks. This is Next.js. It's a server-side rendered framework built on top of React. And this is an implementation of that exact same app we just showed using Next.js instead of Create React app to build it. And so we'll take a quick look at that. And I think the main thing to look at here, so this is the same page, right? It's same, look, everything looks the same. We search for trails, it rendered these trail results. And just to prove to you that this page had been server-side rendered, if you look for some unique string like Appalachian National Scenic Trail, right? That if we view the source of this page, we can see that the table is here, so we can see that that string appears here, and the table itself is all rendered here. So this is something when a search bot looks for this, what they'll see is they'll get this HTML returned back. They'll be able to parse that and understand what this page is about, and it will be helpful for SEO. The code for this looks very similar to the other code, so I'm not going to review it, but it's also under my GitHub account under Next ArcGIS app, so you can check that out for yourselves. So that's pretty much it. This is what I wanted to show and talk to you about. I'm going to hand it over from here to Dave, who is going to talk about some more Node examples at the command line.
Okay, thanks, Tom. So we wanted to wrap this up. I want to talk a little bit about some of the things that I've used RestJS for. And that has to do with building kind of Node power tools. So as a developer, right, I mean, I'm working on the hub, and a lot of the stuff I work on is creating items and applications and web maps and sites and a whole bunch of stuff created dynamically on the fly. And you know, I try and be a really good developer, but as you're writing code, inevitably you're going to create a whole bunch of trash things. This is, you know, you wrote some code, you got 60% of the way through creating something and something broke, right? And that you end up having these items that are in some bad state. You know, if I'm dynamically creating something like a survey 123, then I might have a bunch of services and views that are in a folder and something's broken about them. And when you kind of break these things in interesting ways, you can't always actually cleanly clean up through the ArcGIS home application. So, and even if you can, that can be a very slow process and manual process. So what I've done is I built some Node tools to allow me to really burn things down. And so I'm going to give you a URL to a repo, but I wanted to put some warnings up here. You know, be careful with this code. This, you know, there's code in here that will really it wreaks havoc, right? This is not for the faint of heart. Seriously, be very, very careful if you work with this stuff. So that said, you can go to GitHub dbowman org-cleaner, and this is a very simple set of scripts, and it's stuff that I use on a regular basis to help me clean up the stuff that my user creates. So we'll look at this. You have to I pull in three main things here. This is just, you know, normal Node. I'm not using ESM to run through ES6 modules or anything. I pull in .env, that's so that I can stash my credentials and some other information locally. So I can just run a command. I don't have to pass a whole bunch of stuff into it. And then you have to bring in a fetch library and then a form data library for working in Node. And this stuff's documented in those getting started things. So what do we actually have going on here? Beginning when the script fires up, I go in to bring in a user session, bring in a request, And then I bring in a bunch of these independent functions: get self, get users, get items, search items, and remove item. Then after that, we go and we set up a request options, which is really all the information that we need. This is coming out of my environment file. Again, it's easy. I can run this command. As I said, I do this a lot, right? Like I write code, and as I'm debugging it, I create a big mess of things that I need a clean way to go delete this stuff. So I set up this request options, and then I pass it into just a top level function call called process. From there, this just becomes normal promise-based chaining, just as though if you were doing this in a browser. So it's pretty straightforward in terms of how it kills things. It goes and does a search, gets things back, and then it just calls a bunch of different services. So remove the forms. So this is for getting rid of survey 123 things I've created. Go kill any orphan services. It does a bunch of checks to make sure what's around, what's still connected. Kill is empty. Survey folders, here's this remove services thing. Again, that just removes like all the services. I have it commented out. I've given you many warnings. Just be careful with that. Looking at one of these functions here for remove forms, again, I construct a query. So go find the owner, which is a particular person, type forms, and it has a type keyword hub debug. So I try to set these things up such that whenever I am working in a debug mode, I put extra type keywords on my items, so I know that this is stuff that 100% is not anywhere near something that's needed long term. And then based on that query string, I execute search items. I go and get all of them, and then I map that into a delete form function, which is simply going to go and kill this stuff. So this is this type of thing that you can do. You can go look at the rest of the code that's in that repo. Again, it's super useful if you work against the portal API and you're writing codes. You're kind of building broken items on a regular basis. This is a very, very useful thing to use. I would not recommend it if you're just trying to surgically remove a few things, but you can use the library to do that yourself. So that's really what we've got here for you today. I wanted to thank you very much. The best place to kind of reach out, have questions, so on and so forth, is to put issues up on the GitHub repo. That's github.com/esri/ArcGIS Rest JS. And the documentation is the second URL there, although that one you can just search for Esri ArcGIS Rest request, and you will be taken to our documentation site. So thank you very much.